Hello and welcome to Maths with El Profelo. In this video, we're going to talk about the Legendre symbol as a topic within elementary number theory. Okay, and so let's go ahead and start right with the definition. That we'll say that if P is an odd prime number and A is an integer, where P does not divide A, then the Legendre symbol, denoted right by these parentheses with this A over P, right, is evaluated as the Legendre symbol of A modulo P will equal 1 if A is a quadratic residue modulo P, and will equal -1 if A is a quadratic non-residue modulo P. Okay, so in other words, this Legendre symbol sets up with simplifying some computations in determining whether we have a quadratic residue modulo some odd prime number. Okay, so we'll start with how to evaluate this symbol using something known as Euler's criterion. And that is that when the conditions for the Legendre symbol are true, right? So P is an odd prime number and A is an integer with P does not divide A, then right, the Legendre symbol of A modulo P is equivalent to A raised to the P minus 1 divided by 2 modulo P. Okay, so let's go ahead and use Euler's criterion to evaluate the Legendre symbol 11 modulo 23. So here's what we can say. All right, we can say that 11, all right, modulo 23, the Legendre symbol, will be congruent to 11 raised to the 23 minus 1 divided by 2 power modulo 23. Okay, well, what does that mean for us? What that means for us is that this Legendre symbol modulo 23 will be congruent to 11 raised to the 11th power modulo 23. All right, well, 11 raised to the 11th power is congruent to 22 modulo 23. And what does that tell us? That tells us that therefore this Legendre symbol, right, of 11 modulo 23 will equal 1. Why will it equal 1? Well, 22 mod 23 is equivalent to -1 mod 23. Okay, now some of you might be asking, well, how did you get this value so quickly? This 11 to the 11th is equivalent to 22 mod 23. Okay, well, assuming you have technology available to you, you could come to a website such as Wolfram Alpha and type in 11 raised to the 11th mod 23 and see that you get a result of 22. Okay, now we did speak that this -1 lets us know that 11 is a quadratic non-residue modulo P, and of course we could also use Wolfram Alpha to check out that information for us and say, hey, did we get the information right on computing the Legendre symbol? And we say the Legendre symbol of 11 modulo 23, look what the input looks like, is -1. Right? Important to state that this is not a fraction. This is not a numerator up here. This is not a denominator. This little horizontal bar would not be a vinculum necessarily, but we can think about it as a vinculum. And we can say, hey, the answer should be -1. We went through, we got the answer of -1. Right? Another way that we could check it is to say, hey, if we know what the quadratic residues modulo 23 are, and notice that the quadratic residues do not include 11, therefore the Legendre symbol of 11 modulo 23 must equal -1. All right, so we've got a lot of interesting little pieces here that can certainly help us. And in fact, if I wanted to come in and say the quadratic non-residues modulo 23, all right, I see that 11 is in fact the quadratic non-residue modulo 23, which would imply the Legendre symbol is -1. Okay, now let's say that you didn't have all of that. all you had was your calculator, right? And so you would want to say, okay, well, does 11 raised to the 11th power, let's write this correctly, 11 raised to the 11th power, right, there's a number, very big number, divided by 23, right, there's that number, right? If I say, okay, well, does this have a remainder of 22 modulo 23? That might be quite difficult to see and determine. Okay. Instead, what we might do is the following: is say, hey, 11 squared is 121. On division by 23, that's 5.26. Subtract the 5, multiply by 23, I see that I have a remainder of 6. Right? So if all I had was my calculator available to me and not, this additional technology, I might say that 11 squared is congruent to 6 modulo 23, right? And maybe I check 11 cubed as well to see what results there. Let's see here. Whoops. Multiplied by 28 rather than 23. So let's get back to our decimal. Multiply by 23, and there's 20. So I could say 11 cubed is equivalent to -3 mod 23. Okay. Now, given that 6 is a smaller number than -3, what I'm going to go ahead and do is come in here and say, hey, that would mean that 11 cubed raised to the 3 power times 11 squared, whoops, mod 23 is what I'm looking for here, right? I'm looking for 11 to the 11th mod 23, which I could write in this form, which really I could write as -3 cubed times 6 mod 23. Okay, well, what is -3 cubed? We should know that -3 raised to the 3rd power is -27. If I add 23, I get -4. So this would mean that I have -4 times 6 mod 23, which implies that I have -24 mod 23, which really is just saying -1 mod 23, right? So notice that I would be able to get to the same answer of -1 even if I did not have a system such as Wolfram Alpha to help me figure out that 11 to the 11th mod 23 is 22. Right? That I could figure it out just with my handy dandy calculator here. Really, you could do it with the 4-function calculator as well, as long as your numbers wouldn't get too large, right? But once again, the limitation of your calculator is to say, hey, if I have 11, right, to the 11th power divided by 23, it's going to be difficult to see what that decimal is. In fact, if I want 11 raised to the 6th power, right, divided by 23, subtract the 77,024, right, and multiply that number by 23, I would see that 11 to the 6th power leaves a remainder of 9 on division by 23. And let's see, 11 raised to the 5th power divided by 23, subtract the integer component, find the remainder, and that's basically 5. And so I could also have that I have 9 times 5, which is 45, which is also -1 modulo 23. So different approaches that you could use to figure this out. But hopefully that starts to make a little bit of sense. And that is our first of several examples that we will use to discuss the computation of the Legendre symbol. And once again, what that Legendre symbol simply tells us is whether or not A is a quadratic residue or a quadratic non-residue modulo some odd prime number that is not a factor or a divisor of A. Okay. I thank you for your time. This has been Maths with El Profe Lo.